He's worked on several machine learning projects, including a generative chatbot, an image generation model, some IoT projects, including a smart thermostat and a smart lighting system. And if that wasn't enough, he's also contributed to Darwin X, a nanotech project that aims to accelerate nanotech development with simulation software. And here's the thing that's kind of important. He's only 15 years old. That's right, he's only 15. Let's give him a hand for being 15 and achieving all of this. Mike, you need a mic. I will just say, welcome to the stage, Adar Kahiri, and I will say this. I don't know what it is about this week, this month, whether it's Greta Thunberg or our next speaker. I'm just really happy about what the next generation is building. Let's give him another hand.
Those of you who didn't leave, you're in for a ride. So, like she said, for the past year, I've been working on a bunch of projects in AI, IoT, and while I was looking at how we can apply these technologies to solve some of the world's biggest problems, there was one thing that stuck out to me the most, and that was just how much we waste. 1/3 of the food produced in the world every year is wasted. That's 1.3 billion tons of wasted food. It's crazy. Or how about the Great Pacific Garbage Patch, which is estimated to be 1.4 million square kilometers large. That's like the size of Texas, times 2. But what about the waste that we don't see? So one day I was working with a machine learning algorithm called a GAN. That's me, by the way. So this GAN it stands for Generative Adversarial Network. Don't worry about that. But all you need to know is that it can generate fake pictures of pretty much anything. Cars, cats, people, whatever. So I was looking at some of these pictures of cars that this GAN had created, which look like this, by the way, super realistic, and it got me thinking. How much of this car, for example, which is real, is really useful? There must be some material in this car that's just not adding anything to its structural integrity or strength. It's just dead weight. And there must be a way, I thought, that we could get rid of all of this useless material while keeping the car just as strong and safe, and maybe even more so. So, as any curious person with a burning question would do in 2019, I went to the library. No, I'm just kidding. I went to Google to try to find a way that we could use technology to do just that. And I came across generative design. Generative design is an awesome new way to get computers to get computers to iteratively generate optimal designs based on goals and constraints. So now that we got all the fancy mumbo jumbo out of the way, let me explain what that actually means. So let's take this chair. In order for the computer to design this chair, I need to give it goals and constraints, which is just a fancy way of saying that I need to give the computer an idea of what exactly I want it to design. So in this case, the goals could be for the chair to weigh no more than 3 kilograms and for it to only cost $15 to manufacture. And the constraints could be for the chair to be, or the constraints could be that the chair has to be 1 meter tall and it has to be made out of aluminum using 3D printing. Now realistically you'd have way more goals and constraints, but you get the point. So the computer then iteratively generates hundreds or thousands of possible designs in a process that sort of mimics evolution. This means that the computer figures out which designs work and which don't, and then improves upon the designs that do. And what's awesome about all of this is that the computer doesn't just create designs that look cool, but ones that are actually viable and manufacturable. Each design the computer creates is put through a bunch of simulations to make sure that it can handle all sorts of stressors and that it can actually be made using the material and manufacturing method you choose. So let's see how some companies are implementing this today. Airbus used generative design to create a lighter interior partition for one of its planes. This new partition was almost half as light as the original and just as strong. And this weight reduction will prevent tons, literally tons of CO2 from being emitted into the atmosphere. Now, what if we could remove even more material from the plane and decrease emissions by just 15%? Let's see how that would go. So be prepared. There's a tiny bit of math here. So again, I also couldn't find the numbers on this, so I had to do the math myself. So here it goes. So the average commercial plane emits 90 kilograms of CO2 per hour, and the average commercial plane per hour flight. And the average commercial plane flies around 3,000 hours per year. And there are approximately 12,000 active commercial planes at any given moment. You multiply all those numbers together, and you get 3,240,000 tons of CO2 emitted by commercial planes each year. I wish I could make that much money in a year. So if a 15% reduction would mean 486,000 tons of CO2 saved each year. Now what if we could get similar savings for CO2 for cars, which are an even greater contributor of greenhouse gases? You can kind of start to see how generative design could help us significantly reduce our carbon footprint as a species. You may have also heard of Autodesk, one of the leading generative design companies, who's actually using generative design to create floor plans for different spaces. Based on a bunch of different parameters like different people's work habits, proximity between teams that work with each other, and even where the good window seats are, the computer is able to create floor plans for offices that actually increase productivity. Now, increasing productivity is cool and all, but the implications of this go much further. As the human population grows, and as more and more of these people move into dense urban metropolises, it'll become more and more important for us to use the limited space we have as efficiently as possible. Now keep in mind that this isn't just limited to indoor spaces. We could potentially use generative design to create entirely new cities in developing countries from the bottom up, such that the citizens might not even need to own cars because everything is just within walking distance. Or how about Under Armour, who's using generative design to create the next generation of shoes? They wanted to create a shoe that was stable enough for weight training, but flexible and agile enough for fast-paced activities like CrossFit. Standard designs just couldn't do it, so they turned to generative design to create a shoe that could. This right here, I'm talking about the sole, is something that a human designer could have never come up with on their own. But generative design doesn't just stop there. What if instead of having computers just generate designs, we could have designs that help design themselves? Okay, what is this guy saying? So let's take a look at this race car. This car is a lot more special than it seems. Autodesk researchers collaborated with the Bandito brothers, which is a content creation studio, to give this car's chassis a nervous system made of dozens of sensors. They then gave this car a beating. They drove it around like crazy, which allowed the sensors to gather literally billions of data points about the forces that were acting upon the car. They then fed these data points into Autodesk's generative design software, and with it, the software created this: an optimally designed car chassis that human designers could have never come up with on their own. I think you're starting to see the pattern here. Generative design is part of an overarching trend of machines and humans coming together. We have powerful computers in our pockets and on our wrists, and for some of us on our laps. We have cars that drive themselves, robots helping surgeons save lives, and now computers helping us design in a way that they never have before. Like, none of this stuff even existed 30 years ago. Think about that. So anyway, I think that generative design is going to become, it will be used more and more in the next few years as some of the biggest bottlenecks and challenges in the field are overcome. That'll mean better, cheaper products for us and more sustainable manufacturing for the planet. Thank you.